The shallows of the reef begin with silence, not the emptiness of a void, but the thick, filtered hush of suspended life. Sunlight pours down in waves, fractured by rippling water and scattered across a pale canvas of crushed coral, shell fragments, and sediment. It is not truly still. Faint currents brush across the seabed, shifting grains of sand just enough to disguise the edges of motion. In this landscape of concealment, where every flicker could be camouflage and every patch of nothing might be watching, the stingray reigns.
Beneath this calm, the southern stingray lies half-buried, a mottled disk of muted brown and grey that matches the sandy seafloor with uncanny precision. Its body appears more like a smudge of light distortion than a living creature. Only the slow, rhythmic pulsing of its spiracles betrays its presence as it breathes in from the top and exhales below, disturbing the silt just enough to be noticed, but only if you're looking for it. Its eyes sit high on its head, scanning upward and outward with a low, steady awareness. They are not its primary weapon. Those lie hidden beneath. Along its underside, invisible to anything above, a complex web of electroreceptors called ampullae of Lorenzini registers the faintest electrical signals. The flutter of a fish's muscle, the twitch of a crab's leg. In a world where sound and sight are easily scattered or masked, the stingray detects the bioelectric pulse of life itself. It doesn't move until it must. When the signal sharpens, when it knows its target is too close to retreat, it strikes. With a sudden upward lurch of its wings, broad, muscular pectoral fins, the ray explodes from the sand like a trapdoor opening from beneath. The prey, often a goby or shrimp, has no time to respond. The ray's mouth underneath its body clamps down with crushing force, and within seconds it returns to stillness, burying itself once more in a rising puff of dust. But stingrays are more than ambush hunters. They are architects of the seafloor. Each attack leaves behind a shallow crater, a disturbance in the smooth surface of the sand. Over time, a ray's foraging path forms a mosaic of pits and trails, reshaping the substrate into a habitat of micro-shelters. Small fish follow behind, darting into the overturned sediment to hunt dislodged worms and crustaceans. Cleaner wrasses cruise the perimeter, waiting for rays to pause so they can nibble away parasites. Even crabs and juvenile eels use these foraging scars to hide and hunt. What appears to be a solitary predator is, in fact, a keystone species, reshaping not only its immediate environment, but the feeding patterns of dozens of smaller species that rely on its presence. The dynamics of the shallow reef shift around the ray's behavior. Predator becomes provider in unexpected ways. In some stretches of the Pacific, groups of goatfish trail behind rays like remoras to a shark, hoping to catch the runoff of the stingray's precision strikes. In the Caribbean, juvenile reef fish take up temporary residence in abandoned feeding pits, using the hollows to hide from patrolling jacks and trumpetfish. These relationships are not formal alliances. They are opportunistic, born from adaptation to the stingray's persistent disruption of the seabed. But they show how tightly woven even the most solitary hunter can be into the broader ecological tapestry. Camouflage for the stingray is not a static trait, but a behavior. Its skin is lined with chromatophores, pigment cells that shift hue and intensity to match changing substrates. When the bottom is dark and shell-strewn, the ray becomes flecked and gritty. When the sand is pale and clean, it turns the color of powdered limestone. The edges of its body blur with the terrain, especially in the glare of shallow sun. Unlike cuttlefish, stingrays don't flash or dazzle. Their change is gradual, patient, and almost imperceptible. But that patience makes them invisible until the exact moment they choose to appear. It's not invisibility through absence, it's invisibility through perfection. The mastery of disguise extends beyond the ray itself. In parts of Southeast Asia, the mimic octopus takes on the form of stingrays by flattening its arms and undulating them in wide wing-like pulses as it skims across the sand. This behavior, rare and unsettling to watch, confuses potential predators and prey alike. Is it a ray, dangerous and venomous, or something else entirely? The mimic, like the ray it copies, manipulates expectation to survive. In doing so, it reveals the stingray's own reputation, not just as a predator, but as a presence to be feared. That fear is not misplaced. The stingray's tail is not just decoration or rudder, it is weaponized. Some species possess long, barbed spines lined with venom glands capable of inflicting excruciating wounds.
While rarely used in predation, the tail serves as a last line of defense, lashing upward if the ray feels cornered or threatened. It is a deterrent more than a tool, but a powerful one. Sea snakes, known for their own lethal venom and audacity, will sometimes target rays as prey. But to succeed, they must approach without triggering the ray's defenses. In this strange reversal of roles, the snake becomes the cautious stalker, weaving a slow, deliberate path across the sand, hoping to land a bite before the tail reacts. More often, though, it is the rays who must watch their backs. Larger predators like hammerhead sharks have developed specialized hunting strategies for stingrays. The hammerhead's wide, sensory-laden head can pin a ray to the bottom, while its jaws tear into the soft flesh. In certain reefs, entire schools of rays will migrate together, not for social bonding, but for safety in numbers. The rays remain solitary by nature, but they tolerate proximity when the risk of predation rises. These migrations are silent, ghostly formations that move across lagoons like shadows of the reef itself, lifting puffs of sand in synchronized flight. Not all rays remain in the shallows. Some species venture to the edge of the reef, gliding along drop-offs and outer slopes where the light dims and the water cools. Here, the dynamics shift again. The open water offers fewer places to hide, and the stingray's camouflage becomes less effective. But even in these exposed zones, rays rely on their ability to read the seafloor, to detect subtle changes in electric field and terrain that guide them toward food or safety. And still, where they hunt, others follow. Garden eels retract as rays approach, then emerge once they pass, feeding on the detritus stirred from the sand. It's an unspoken system, predator, prey, and passerby all playing their roles in silent succession. In the end, the stingray's brilliance lies not just in how it kills, but in how it reshapes the world around it. With each undulation of its wings, it changes the topography of the ocean floor. With each ambush, it feeds not just itself, but the many lives that benefit from the aftermath. It is not the apex predator of its domain. Others are stronger, faster, more lethal. But few are as influential. The stingray hides in plain sight, not to avoid attention, but to control it. And in doing so, it becomes one of the most quietly powerful forces in the reef, a shadow that leaves ripples long after it's gone. The water here is shallow, warm, and green-tinted, stretching in lazy sweeps across coastal flats that seldom make the maps. Sunlight filters through the surface in wavy ribbons, casting a mosaic of motion across the gently swaying blades of seagrass below. No coral towers or jagged rocks rise here, just a broad, open underwater pasture, deceptively still. But beneath this apparent quiet, a massive process unfolds, and drifting just above the sea floor, like a grey submarine smoothed by time and tides, comes the dugong. It moves slowly, deliberately, propelled by a rounded tail that resembles that of a whale, but belongs unmistakably to a mammal of the shallows. Its body, stout and torpedo-shaped, gives off a faint shimmer in the sunlit water, not flashy, but noticeable against the green seagrass. The dugong does not hunt. It does not chase or ambush. Instead, it grazes. Its large, bristled lips curl downward as it lowers its face into the swaying vegetation. With every pass, it uproots clusters of seagrass, pulling entire plants from their roots and swallowing them whole. And in doing so, it begins to rewrite the landscape. Unlike fish that nibble or scrape, the dugong's feeding is wholesale, methodical, heavy, and transformative. Each bite creates a gap, a clearing in the meadow, exposing the sandy substrate below. Over the course of a single morning, a feeding dugong can clear broad trails through the grass beds, like paths left by a plow. These clearings, however, are not mere scars. They become entry points for light, oxygen, and change. As the dugong moves on, the disturbed areas begin to fill with different life. Microalgae bloom in the open sunlight. Juvenile fish take refuge in the edges between cut and uncut grass, and filter feeders emerge from the sand to catch drifting particles dislodged by the grazer's passage. This role, as ecological engineer, is one rarely acknowledged in creatures so slow and seemingly passive. But the dugong's behavior shapes more than just plant life. Certain fish species, like rabbitfish and juvenile wrasses, follow closely behind, darting into the sediment plumes stirred by the dugong's snout and tail. They feed on the tiny invertebrates unearthed by the disturbance. Crabs move in later, combing the area for leftovers. And hidden among the sediment, camouflaged nearly to perfection, are ambush predators waiting for their opportunity. The stonefish lies motionless until it doesn't. Buried beneath a thin layer of sand or nestled among the remaining grass, it mimics the texture and color of rubble or coral. The vibrations from a grazing dugong often alert it to potential prey, not the mammal itself, but the smaller fish stirred into a panic by the disruption. Stonefish are sluggish movers but lightning-quick strikers. With a vertical snap of their jaws, they inhale their prey whole in less than 200th seconds. Dugongs don't fear them, but many of the species that trail the dugong do. And in this odd web of indirect interaction, the dugong acts as both provider and unwitting accomplice to predation. Another ambush predator, the crocodile flathead, relies on similar tactics. Flat, spined and dust-colored, it waits along the trail of a feeding dugong, timing its strikes with precision. Some dugongs, older and more experienced, seem to recognize the rhythm of these ambush zones. They pause, hover briefly, and then redirect, sometimes doubling back in wide arcs to avoid the risk-laden corridors. This isn't fear so much as strategy. The dugong, though often labeled simple, possesses spatial memory and behavioral flexibility far more developed than its reputation suggests. There is irony in how such a gentle grazer influences predator behavior on such a scale. Nowhere is this more visible than in the clear, turquoise shallows of Shark Bay, Australia, one of the most heavily studied dugong habitats on Earth. Here, the movements of dugongs are anything but random. Their feeding grounds shift by the week, and not always because of grass density. Instead, they respond to shadow. Above, cruising the deeper waters just beyond the seagrass, the tiger shark patrols. Bold, unpredictable, and perfectly suited to ambush in the open, tiger sharks are among the few predators capable of taking down a dugong. They do so with sudden attacks, often from the side or below. Dugongs are fast when they need to be, capable of powerful bursts of speed using their paddle-shaped tails, but over distance they tire quickly. This dynamic has shaped an underwater arms race. The dugong avoids certain areas during peak tiger shark presence, while the shark uses learned patterns to predict the dugong's preferred paths. Recent studies have revealed something even more fascinating. Using satellite tagging and drone footage, researchers discovered that tiger sharks in Shark Bay actively track dugong movements, not just locally, but across broad coastal ranges, following their seasonal migrations and adjusting their patrols accordingly. In some areas, dugongs will completely abandon lush seagrass beds if they detect sustained shark activity, leaving those meadows untouched for months at a time. These no-go zones become sanctuaries for regrowth, maintaining ecological balance not by direct planning, but through fear-driven avoidance. This fear has ripple effects. When dugongs vacate a region, the fish that followed them vanish too. Algae blooms are altered. Nutrient cycles shift. Even shoreline erosion patterns can change due to sediment stabilization or loss. In this chain, dugongs, grazers with no claws, no teeth, no armor, become unwitting regulators of entire marine food webs. Their feeding creates balance, but their absence is equally impactful. Dugongs are not solitary by rule, but neither are they strictly social. In some locations, small herds will graze together, loose aggregations of half a dozen individuals, usually related females or juveniles. The movement of these groups creates vast, visible trails through the seagrass, like brushstrokes across the seafloor. When these groups converge, often during migration or after storms, their collective grazing can clear entire hectares of grass in just days. It looks destructive. But unlike human harvests, the dugong doesn't overconsume. It moves, rotates feeding zones, and by doing so, prevents monocultures from dominating the grass beds. Biodiversity in many areas is highest not where the grass is untouched, but where it is regularly trimmed. Their method of grazing also prevents buildup of decaying vegetation, which otherwise would smother coral or lead to oxygen-depleted zones during breakdown. In essence, dugongs perform the same role on the underwater plains that elephants perform on savanna grasslands, shaping habitat not by aggression, but by persistence. Their impact is slow but cumulative, unfolding over months, seasons, even years. This influence stretches across continents. Dugong populations, while fragmented today, once connected the Indian Ocean to the Western Pacific. From the coasts of East Africa to the Philippines, Dugongs historically served as ecosystem managers of the shallow tropics. Where they vanished, through hunting, habitat loss, or boat collisions, the grass beds often changed irreversibly. Overgrown fields turned to algae-choked mudflats, losing the clarity and richness that once supported reef fish nurseries and juvenile crustaceans. Even in areas where dugongs have returned under protection, the full recovery of seagrass systems takes decades. This isn't just about the presence of grass. It's about its structure, species composition, and the movement-driven pruning that only a dugong can provide. And yet, despite their ecological significance, dugongs are elusive. They leave few visual signs and make little sound. Their migrations are long, but quiet. Their impact, while massive, is subtle in form. They carry no weapons, strike no fear into divers, and leave no blood trails in their wake. But every patch of balanced seagrass, every nursery where juvenile fish take shelter, every ambush corridor now thriving with fish and benthic predators, each of these holds a signature shaped by the dugong's mouth and the movement of its body across the ocean floor. What they offer is not spectacle, but stability. And in the underwater world, stability is rare. The dugong grazes not to make a point, but to survive. And in doing so, it sustains a continent of life beneath the waves. At first glance, the Napoleon wrasse doesn't look like a predator. In fact, it barely looks like it belongs in the same world as sleek barracudas or stealthy reef sharks. With its swollen forehead, fleshy lips, and scales that shift from green to blue in the light, it appears more like a caricature of a fish than a hunter. Yet beneath that ponderous form and sluggish glide lies a force capable of reshaping the very infrastructure of the reef. In the twisting canyons and undercut ledges of the Indo-Pacific coral systems, the Napoleon fish is not merely a grazer or browser. It's a specialist thief, a brawler, and a key that opens vaults no other fish can crack. The reef is an armored fortress. Beneath its colorful exteriors lie hard-shelled clams, toxic sea slugs, and venom-laced starfish, all protected by biology, geometry, or chemistry. Most reef inhabitants either avoid these hazards or peck cautiously at the edges. But the Napoleon wrasse is different. It seeks out what others leave behind. With jaws strong enough to crush the calcium carbonate shell of a giant clam and the thick outer armor of a crustacean, it forages not by grazing, but by breaking in. A feeding adult doesn't drift gently across coral gardens. It targets pressure points, hovering above rubble-filled crevices and inspecting each cavity with slow, methodical turns. When it finds something worthwhile, it strikes, lips pressing forward in an almost comical pout, then retracting with a violent bite that snaps through shell and coral alike. Its menu reads like a list of biological warning labels. Crown-of-thorns starfish, which devastate coral colonies and are avoided by most predators due to their venomous spines, are prized by the Napoleon fish. So are toxic sea hares, bristling fire urchins, and mantis shrimp that can deliver punches strong enough to crack aquarium glass. These are not fallback meals. They are delicacies, taken not out of desperation, but with clear preference. Scientists have observed Napoleon wrasses using a combination of strength and precise technique, flipping starfish to expose their vulnerable underbellies, or slamming shelled animals against coral heads to break them open. It is not chaos, but calculated violence. And in the reef's delicate architecture, that violence leaves marks. A single feeding event may scatter shards of coral, dislodge cryptic species hiding in crevices, and attract a cascade of secondary feeders. Moray eels slink out from their burrows to inspect the aftermath. Octopuses, sensing exposed mollusks or crustaceans, drift down to scavenge what's been broken loose. Triggerfish arrive last, bold and opportunistic, picking through the leftovers with their chisel teeth. The Napoleon fish has no need to guard its kill. Its act of destruction becomes an unintentional buffet. This ripple effect means that one predator's action creates a brief but intense window of opportunity for multiple others, a kind of mobile feeding front that reshapes the energy flow through coral microhabitats. And yet, for all its size and strength, adult males can reach 2 meters in length and weigh over 180 kilograms, the Napoleon wrasse is not reckless. It exhibits a level of spatial memory rarely seen in reef fish. Individuals return to the same coral vaults seasonally, remembering which overhangs house giant clams, where spiny urchins hide beneath plate corals, and even which cracks have been recently picked clean. In some documented cases, wrasses were seen circling back to a foraging site days later, bypassing depleted zones and heading directly to untouched targets. Behavior that suggests not instinct, but learning and recall. Occasionally, this strategy expands beyond solo missions. In certain reef systems, Napoleon wrasses have been observed in loose association with goatfish, slender, whiskered bottom feeders that flush small creatures from the sand with their barbels. The goatfish disturb crustaceans and mollusks from hiding, and the wrasser follows, waiting for a surge of movement or a dislodged shell to strike. It's not true cooperation. There's no evidence of coordinated behavior, but it's an opportunistic alignment, one predator benefiting from the disruptive habits of another. In these moments, the reef's predators form fluid, temporary alliances driven by hunger and chance. Beneath ledges where sunlight barely reaches, other forms of this feeding network emerge. When a wrasser breaks open a patch of sponge-covered coral, it can displace more than just its prey. Silt clouds the water. Algae detritus drifts upward. Microcrustaceans scatter. Cleaner wrasses and anthirs emerge to feed on the fallout. Even corallivores, fish that feed primarily on coral, may take the chance to nibble at freshly broken branches. The initial destruction becomes a pulse of activity, a momentary burst of resource availability in a system that normally operates under strict spatial constraints. Despite their bulk, Napoleon wrasses are not apex predators in the traditional sense. Large reef sharks, especially in less protected waters, will occasionally target younger individuals. But the wrasser's real vulnerability lies not in its ecology, but in its relationship with humans. Its enormous size, slow growth, and striking appearance have made it a prized catch for live reef fish trades and luxury seafood markets across Southeast Asia. Many adult males never reach their full size, and in areas of high exploitation, their absence alters the reef structure in subtle but lasting ways. Clams grow larger without pressure. Crown of thorns outbreaks become more common, and the cascade of secondary feeders lose one of their most consistent meal triggers. Beyond the biology, there is a strange visual poetry in watching a Napoleon fish feed. Its body undulates with slow, careful movements, almost lazy, until it strikes. Then in a flash, that bulbous forehead, often likened to a human nose or a ceremonial helmet, lunges forward with unsettling speed. The sound underwater is brief and blunt, a dull crack of shell meeting bone-reinforced jaw. Nearby, fish scatter for a moment, then drift back in. The reef settles, and the wrasser moves on, following memory, hunger, and a mental map built not on instinct alone, but experience. In the patchwork world of coral reefs, where space is limited, shelter is fiercely defended, and food is often hidden behind layers of armor or poison, the Napoleon wrasser carves a niche through force and finesse. It is a vault breaker, a specialist in the improbable, and a catalyst for motion in a world that thrives on disruption. Its methods are messy, even brutal, but the effects are indispensable. In every crack opened, every meal torn loose, and every ripple of movement it leaves behind, the reef adapts, not in spite of the chaos, but because of it. In the shallows where reef meets sand, the water moves with a slow rhythm, pushed gently by tides rather than waves. Light filters through in wide bands, and below the surface, a green sea turtle glides, deliberate, unhurried, as if time itself works differently in its presence. It drifts just above the reef, close enough to cast a faint shadow across the algae-covered rocks, but never in a hurry to touch them. Its flippers sweep the water with slow, circular strokes, propelling it in wide arcs over its feeding grounds, following a route that may have been etched into its instincts millions of years ago. The green sea turtle, Chelonia medus, is often imagined as a gentle herbivore, an underwater grazer that spends its life browsing algae and seagrass. And for the adults, this is largely true. But beneath the polished shell and tranquil motion lies a complex and dynamic existence shaped by age, geography, and shifting diets. Juvenile green turtles don't begin their lives as peaceful plant eaters. Instead, in their early years, they live a life closer to scavenger than grazer, drifting in the pelagic zone, feeding on jellyfish, salps, and even floating carcasses when available. They ride ocean currents across vast distances, barely touching land or reef, surviving on what the open sea offers. These young nomads blend the roles of predator and detritivore, not elegant but effective. It isn't until several years in that they return to coastal waters, often hundreds or even thousands of kilometers from their hatching beach. Only then do they shift to their better-known diet of seagrass and algae. and even then their preferences can vary with availability. In some areas, turtles have been observed scraping algae from rocks and coral rubble with their finely serrated jaws, while in others, they target softer, filamentous species that grow in nutrient-rich shallows. These feeding habits leave visible signs: scrape marks along reef flats, trails of disturbed sediment, and clusters of small fish that hover near the turtle's mouth to catch drifting particles. This feeding doesn't occur in isolation. The turtle, though solitary by nature, is often accompanied. Sea cucumbers trail along the bottom, filtering through turtle-disturbed debris for edible matter. Surgeonfish and tangs dart beneath its belly, grabbing loosened algae and picking at the turtle's skin for parasites. Even butterfly fish sometimes linger, probing the edges of its carapace for scraps. These are not partnerships born of communication or trust, but of opportunity. The turtle grazes, and the reef responds. At certain points in its foraging route, the turtle pauses near designated cleaning stations, coral bommies or outcroppings frequented by cleaner wrasses and shrimp. It hovers motionless, flippers adjusting only slightly to maintain position as the cleaners move in. Wrasses flit along its neck and limbs, removing dead skin and parasites, while cleaner shrimp wave their antennae before hopping aboard. This interaction, though brief, is precise. The turtle tilts slightly, angles itself to allow better access, and waits. It is a quiet exchange seen across species lines. Similar behavior is observed in reef manta rays, groupers, even sharks. And it reveals something often overlooked. Turtles participate in social rituals of hygiene that maintain reef health in subtle ways. The turtle's role expands far beyond the reef, however. When nesting season arrives, adult females return to the very beaches from which they emerged, some navigating thousands of kilometers using magnetic orientation and celestial cues. There they crawl ashore under cover of darkness, dig deep nests with their rear flippers, and deposit dozens of eggs before covering the chamber and returning to sea. The hatchlings that survive will face a gauntlet of predators: birds, crabs, fish, and only a handful will reach maturity. But what the turtle leaves behind has consequences far beyond reproduction. The eggs themselves, and those that don't hatch, become a vital nutrient source. Beach crabs feast on broken shells and spoiled eggs. Shorebirds scavenge the leftovers. Even vegetation benefits. The nitrogen and phosphorus leached from decomposing eggs enrich the surrounding sand, fertilizing dune plants and, in some regions, helping coconut palms thrive. The turtle, in essence, becomes a conveyor belt of nutrients, drawing productivity from the ocean and redistributing it across terrestrial systems. These connections deepen beneath the waves. In areas of heavy turtle grazing, seagrass beds exhibit higher productivity. The grazing trims older leaves, encouraging new growth and increasing the bed's capacity to sequester carbon and host invertebrate life. Grazing also prevents overgrowth of epiphytes, small algae and organisms that settle on seagrass blades, which, if left unchecked, can smother the plant and reduce light penetration. By trimming these fields, turtles maintain biodiversity and habitat quality, not just for themselves, but for species that rely on the beds as nurseries: pipefish, seahorses, juvenile parrotfish, and countless invertebrates. But the turtle's behavior does not go unnoticed. Reef sharks, particularly blacktip and lemon sharks, patrol areas known for turtle activity. While adult turtles are generally too large for most reef predators to tackle head-on, the young and injured are vulnerable. Sharks often linger near cleaning stations, where turtles become momentarily less mobile, or stalk the deeper channels between feeding grounds and resting sites. Some turtles bear the scars of past encounters, crescent-shaped gouges in their shells, bite marks along their limbs. Others do not survive. It's a calculated risk. The reef provides food and care, but also brings exposure. Even humans factor into this equation, often with disproportionate impact. In many regions, turtles are threatened by plastic pollution, mistaking floating bags for jellyfish, or by boat strikes, especially in shallow tourist zones. Their grazing grounds can be damaged by dredging, coastal runoff, or invasive algae. Despite these pressures, turtles display an astonishing fidelity to place. Individuals have been documented returning to the same feeding reef year after year, following familiar routes across the benthos, resting under the same coral arches or sand shelves, as if tethered not just by instinct but by memory. This memory, though difficult to measure, suggests a level of environmental awareness often attributed only to more cognitively complex animals. In some studies, turtles have altered their behavior in response to reef degradation, shifting grazing to healthier patches or avoiding areas recently disturbed by human activity. Whether this reflects true learning or simply behavioral flexibility remains a topic of research, but it underscores the depth of interaction between turtle and environment, not passive usage but active response. Through it all, the turtle's presence remains consistent, a slow, deliberate figure navigating an ecosystem in flux. It is not fast, not aggressive, not showy, and yet its influence touches multiple layers of the reef. From the algae it prunes, to the fish that trail its shadow, to the land that grows taller from the nutrients it leaves behind. The green sea turtle moves not just through space, but through ecological roles, as predator, gardener, patient, and carrier. In a reef system often defined by rapid movement and sudden violence, the turtle's role is built on endurance. It does not carve through water like a shark, nor strike with the speed of a moray. Instead, it persists, across years, migrations, and life stages, altering its ecosystem not with force, but with rhythm. Each scrape of algae, each pause at a cleaning station, each nesting crawl up a moonlit beach, is part of a larger cycle that, over time, shapes the algal realms it calls home. The current moves slow and heavy across the reef slope, tugging gently at soft corals and draping strands of plankton like invisible banners in the open water. Above the reef, the light changes. A shadow passes, not abrupt like a predator's dart or the jagged profile of a shark, but smooth, rolling, expansive. The water darkens in slow motion. Below, fish scatter, not in fear but in recognition. A giant has arrived. The reef manta ray, Mobula alfredi, sweeps overhead with the scale of a small car and the grace of a sail caught in silent wind. Its cephalic lobes curl forward like antennae, guiding microscopic prey into its gaping mouth as it glides just meters above the coral. The ray's wingspan, often exceeding 4 meters, is not flapped but undulated. A slow, rhythmic pulse that drives it through water with minimum resistance and maximum control. There is no panic in its movement. Mantas are filter feeders, consuming plankton suspended in the water column. But to find food in the open sea, a domain without walls, trails, or boundaries, requires more than motion. It requires memory, learning, and an almost architectural approach to space. These rays don't wander aimlessly. In nutrient-rich upwellings, especially along outer reef slopes and island drop-offs, mantas return to specific feeding grounds with clockwork precision. Some of these sites bloom with plankton for only a few days each month, triggered by tidal cycles or seasonal currents. Yet mantas arrive early, circling the water in wide, spiraling loops, forming vertical columns of motion, known as feeding cyclones, where each ray rides the wake of the others, funneling plankton into tight bands. It looks almost choreographed, but no leader directs the group. The rays adjust in real time, responding to current direction, density of prey, and even the angle of sunlight, which affects visibility. At times, mantas don't feed in groups. They come alone, hovering near coral outcroppings or rocky islands, where eddies form from the deflection of water. Places where plankton concentrates, suspended for just a moment longer than in open current. Here, mantas use an unusual tactic. They blow bubbles, rising from the gill slits or rolled out from the mouth. These bubbles disturb the water column and help redirect floating prey. Whether the behavior is purely manipulative or serves to disorient plankton is unclear, but it offers a rare glimpse into a foraging style that relies not just on filter and swim, but on technique. Among fish, manta rays are exceptional in another way. Their brains, relative to body size, are the largest of any known species of ray or shark, and among the largest in all fish. This neural investment is not for raw hunting ability. Mantas do not need to calculate ambush angles or ambush prey in tight spaces. Instead, their intelligence appears to serve spatial awareness, social interaction, and long-term memory. In observational studies, individual rays have been seen returning to the same reef structures over spans of years, not just for feeding, but for cleaning and possible rest. At known cleaning stations, they hover for long minutes, positioning themselves at angles that suggest familiarity with the layout and depth of the terrain. Their behavior is not reactive, it is composed. These cleaning stations offer a moment of stillness in a life otherwise defined by endless motion. Reef wrasses and shrimp emerge from crevices and set to work, plucking parasites from the manta's skin, cleaning wounds, even entering the gill slits. During these sessions, rays can appear to queue, one hovering nearby as another receives attention. While it's tempting to anthropomorphize this behavior, it speaks more to their consistent patterns of interaction and possible social tolerance. Mantas aren't schooling fish, but neither are they solitary drifters. Their paths cross often, and when they do, the interactions are calm, even coordinated. One of the most intriguing aspects of manta behavior has emerged not through direct observation, but through photographic records. The underbellies of manta rays are patterned with dark blotches, unique spot formations formed by pigment cells in the skin. These patterns don't change over time, and researchers now use them like fingerprints. With high-resolution imaging, individuals can be identified and tracked across vast distances. Some have traveled hundreds of kilometers between reef systems, crossing political boundaries and ecological zones. The patterns, sometimes jokingly referred to as ocean QR codes, have allowed scientists to map not only migration routes, but also social networks, identifying rays that repeatedly associate at the same cleaning or feeding grounds. These codes have revealed something unexpected. Certain rays, particularly females, appear to form loose aggregations that persist across years. They don't travel as a group, but they meet in the same areas, often during mating seasons or during plankton blooms. Males will trail females during these periods, mirroring their movements, twisting and looping in choreographed acrobatics. Part of a courtship ritual that, though lacking in overt aggression, is highly competitive. Only the most persistent males are rewarded, and mating when it occurs is brief but intense, with the pair twisting downward in spirals before parting. Despite their enormous size, manta rays are often accompanied. Beneath their massive bodies swim smaller species: pilotfish, remoras, juvenile jacks, even small trevally. These riders use the manta as both shield and bait, darting out to catch startled shrimp or to take shelter when predators approach. The relationship is one of passive tolerance. The ray gains little, but it loses nothing. In return, its underside becomes a microhabitat, a floating reef of opportunity for the opportunists. Yet life for mantas is not free from threat. In deeper channels, where visibility drops and the plankton thins, reef sharks and even tiger sharks may attempt opportunistic strikes. The rays' only defense is their speed and agility, attributes that often go unnoticed due to their slow, deliberate cruising in calm waters. But when startled, a manta can launch forward in a burst, twisting sharply with a flick of its wing and disappearing into the gloom. Even large sharks struggle to match them over distance. Still, some rays bear scars, crescent-shaped wounds along the pectoral fins or torn edges near the tail. These are reminders that in the open ocean, size and intelligence don't guarantee safety. The greatest danger, however, does not come from predators. Human activity, particularly in the form of targeted fishing for gill rakers used in traditional medicine, as well as bycatch in drift nets, has decimated some manta populations. Their slow reproduction, with females giving birth to a single pup after a gestation period exceeding a year, makes recovery difficult. Many rays also suffer injuries from boat strikes, especially near tourist-heavy cleaning stations. And though ecotourism has offered financial incentives for protection in some regions, in others, unregulated diving has disrupted cleaning behavior and increased stress. Still, manta rays endure. Their migratory routes span oceans, and their presence, massive, silent, and undeniably intelligent, is a reminder that not all ocean predators rely on teeth or toxins. Some, like the manta, use memory, awareness, and learned behavior to navigate a world of subtle cues and shifting patterns. They are not hunters in the traditional sense, but architects of motion, shaping ecosystems through disturbance and flow. To witness one gliding overhead is to watch something ancient, but not primitive. The manta's every movement is a negotiation with current and light, a decision made not by instinct alone, but by a brain shaped for more than survival. In the deep blue corridors of the reef beneath the open sky of water, the manta ray does not just live. It reads, it remembers, and it returns. Far from the coastlines, where coral gives way to darkness and the reef's color and clamor dissolve into a vast open plain of blue, the water takes on a different quality. It is no longer the busy shallows, no longer structured by rock or root. It is open, utterly, endlessly open. There are no boundaries here. No fixed landmarks. The sun filters down through the water in shimmering gradients, casting a shifting silver roof above a world that seems to go on forever. This is the pelagic zone, and here, among the rolling silence of the open ocean, the blue shark patrols. From a distance, it seems an illusion. Its form barely disturbs the water, slicing through the current with almost no motion. Only when the light catches the length of its body, a shade so vivid and iridescent it nearly vanishes into the water, does its presence become clear. The blue shark, Prionache glauca, is designed for range, not stealth. It doesn't rely on ambush from cover, because out here there is no cover. Instead, it uses fluidity, shape, and an uncanny ability to sense weakness in the ever-moving field of ocean life. Its body is slim, almost eel-like in silhouette, with long pectoral fins that angle like glider wings, allowing it to conserve energy across vast distances. The snout tapers to a point, giving the entire animal a profile more needle than blade. This is a shark made for migration, capable of traveling thousands of kilometers across oceans, crossing equators and thermoclines, drifting between hemispheres not in isolation, but in company. At times, blue sharks gather in sprawling schools, sometimes over 100 strong, organized not with rigid structure, but in a rolling, ever-shifting swarm. Within these formations, individuals constantly change position, moving between inner and outer lanes, adjusting their spacing and depth. This isn't chaos, it's a living current of predators. When the school breaks into hunting mode, the transformation is immediate. The loose, elegant motion gives way to tight, spiral formations. Prey, often squid, sardines, or mackerel, find themselves encircled with precision. Blue sharks do not barrel in wildly. They probe first, circling, feinting, testing for gaps in the school's defenses or the hesitation of a sick individual. Their movements mimic the tension of fencing, each shark a blade probing for the perfect angle. When the strike comes, it is fast, not in the explosive way of reef ambush predators, but in a sudden dart, often preceded by a flick of the tail and a slight roll of the body. Then it returns to the periphery, reassuming position, waiting for the next opening. It's not a feeding frenzy, it's a cycle. Along their flanks, remoras cling, those streamlined hitchhikers with suction plates on their heads, riding the shark's slipstream in search of discarded scraps and a safe escort. The remoras, in turn, serve a purpose, removing parasites, dead skin, and occasionally alerting the shark to subtle changes in water chemistry. But the blue shark's movement does more than host hitchhikers. It cuts invisible corridors through the pelagic zone, transient trails that smaller species follow. Schools of squid shadow their passage, using the shark's form as a break in the current. Lanternfish rise and fall in synchronization with their depth shifts. Even seabirds like petrels and shearwaters trail above, watching for signs of surface tension, indicators that the sharks are feeding and that flying fish might be leaping for their lives. And those flying fish often find refuge in the most unlikely of places: garbage. Drifting mats of plastic and human refuse have become accidental ecosystems in the pelagic realm. Floating crates, tangled nets, and abandoned buoys host algae, barnacles, small crustaceans, and eventually fish. Juvenile jacks, filefish, and flying fish all seek shelter beneath these structures. Blue sharks have learned this. Though not surface feeders by default, they occasionally detour toward flotsam, circling the debris with the same spiral tactic used for bait balls. When the fish flush, the shark strikes. It is a strange intersection of biology and pollution, one that reveals not just the shark's adaptability, but its evolving relationship with a changing ocean. The sensory systems of blue sharks are attuned to this complexity. Like other sharks, they possess electroreceptors in their snouts, allowing them to detect the faint electrical fields emitted by living tissue. But in the open ocean, where prey may be dispersed over kilometers, smell becomes just as critical. A single drop of fish oil or squid ink can be detected from hundreds of meters away, and the shark's olfactory organs, extending deep into the head, map the gradient of scent as it moves. It follows this gradient not in straight lines, but in looping arcs, adjusting its trajectory with each pass until the target is triangulated. Combined with their exceptional vision, particularly tuned to the blues and grays of the open sea, blue sharks can track prey with uncanny precision. They are also not bound to the surface. Blue sharks are known to dive hundreds of meters in search of prey, especially in tropical zones where surface waters may become too warm. Their physiology, while not built for the cold in the way of deep-sea sharks, allows for short plunges into cooler layers. During these dives, they enter the world of vertical migrators, creatures like hatchetfish, bristlemouths, and deep-water squid that rise toward the surface at night and retreat at dawn. Blue sharks time their ascents accordingly, intercepting these creatures at the edge of their range. The females, larger and heavier-bodied than males, often venture farther into open ocean, traveling solo across entire gyres. Their thick skin, nearly twice the thickness of the males, is believed to be a defense against the biting courtship rituals that characterize blue shark mating. Scars from such encounters are common, and females often bear the cost of reproduction both physically and behaviorally. After mating, they disappear into remote offshore waters, giving birth to live pups that are fully formed and independent at birth, a strategy that increases their survival odds in a realm with few hiding places. Predation on blue sharks is rare but not absent. Larger sharks, makos, great whites, occasionally take juveniles. Killer whales have been documented striking adult blues in coordinated attacks. But their real threat again comes from human activity. Longline fisheries, targeting swordfish and tuna, incidentally catch blue sharks in staggering numbers. They are one of the most frequently caught shark species globally, often discarded due to low commercial value. Yet their ecological value is immense. As mid-level predators, they regulate populations of squid and schooling fish, shaping the pelagic food web not through dominance, but through persistence. In the end, the blue shark is a traveler, a mover that ties distant oceanic systems together. It bridges temperate and tropical zones, connects plankton blooms with predator migrations, and brings structure to a place otherwise defined by emptiness. There is no reef to hide in, no seafloor to hug, no cave to call home. There is only movement, direction, and timing. The blue shark survives because it never stops. Its form is built for distance, its senses for the unseen, and its behavior for the unpredictable. It is the ghost blade of the open sea, always in motion, always watching, always cutting forward through the blue. There is a moment of stillness on the reef when nothing appears to move, but everything is watching. Tiny fish hover above coral heads, suspended like fragments of dust in water. A school of juvenile jacks flutters nervously in the mid-water, shifting back and forth as if anticipating a decision they don't want to make. Sunlight cuts through the surface in beams, refracting across the sand and illuminating the scene with a flickering brilliance. And just outside this light, partially veiled in the shimmering water column, a long, lean figure drifts. Not swimming, not lunging, simply waiting. It is a barracuda. Few predators in the reef environment carry the same visual tension as the great barracuda. Its body is unmistakable, elongated, silver and rigid, with a head that tapers into a cruel set of jaws lined with uneven, dagger-like teeth. It seems carved from steel, built not for endurance or subtlety, but for impact. But the barracuda is not a reckless charger. It does not chase prey across the reef in dramatic pursuit. Instead, it uses patience, positioning, and proximity to do something far more effective. It traps. A lone barracuda often positions itself just beyond the main activity zone, near the edges of schooling fish or close to passages where smaller predators like groupers and wrasses operate. It doesn't need to reveal itself. The flash of its scales, when it turns slightly in the light, is enough to make prey hesitate. The shimmer functions like a false start in a race, a bluff that keeps schools fragmented, jumpy, and exposed. The fish don't know whether to flee, and that hesitation is all the barracuda needs. It uses water clarity and solar angle to create a mirage of sorts. Its body reflects light so cleanly that from certain angles it seems to vanish into the column, a silver echo of the sunlit surface. When it does strike, it does so with terrifying efficiency. One flick of the muscular tail and it lunges forward in a straight explosive burst, jaws opening wide just before contact. There is no warning, no acceleration curve, just a snap and the sudden absence of a fish. But this hunting strategy extends beyond the ambush of small fish. Barracudas are infamous for shadowing other predators. They trail hunting groupers, large wrasses, and even reef sharks, not out of curiosity, but for opportunity. These larger predators stir up the reef, flushing prey from cracks and coral heads. As goatfish and groupers probe into the reef structure, small fish dart into the open, and this is where the barracuda makes its move. It doesn't contribute to the hunt. It simply waits for the distraction to create vulnerability. In this way, it often benefits from the hard work of others, a kind of marine opportunist that plays both lurker and thief. This behavior has ripple effects across the reef. Fish schools that might otherwise bunch together for safety, such as jacks, fusiliers, or silversides, often break apart or move away entirely when a barracuda is nearby. The presence of this single predator can force prey into less favorable areas, driving them towards stronger currents or open sand where shelter is sparse. This redistribution in turn affects how other hunters operate. Moray eels may remain in their crevices longer. Snappers and groupers shift their patrol zones. The barracuda doesn't just hunt, it manipulates. Its territorial behavior compounds this influence. Though not overtly aggressive toward other large predators, barracudas are known to disrupt hunting patterns simply by occupying key corridors, particularly reef channels or drop-offs where fish movement is concentrated. Some reef predators appear to avoid hunting near them entirely, not out of fear, but due to the disruption they cause. A barracuda's presence can dissolve a bait ball before a coordinated hunt even begins. In the language of the reef, it is not a loud voice, but an imposing silence, a stillness that forces reaction. Yet for all its prowess, the barracuda is not invincible. Juveniles are hunted by larger reef predators, including sharks and giant trevally. Even adults can fall victim to concerted attacks by top-level carnivores like reef sharks, particularly when caught in shallow, confined spaces. Their strength lies not in dominance, but in precision and calculation. They rarely take risks. They don't have to. A darker aspect of the barracuda's story lies in its connection to the reef's chemical web. In many tropical regions, particularly around the Caribbean and Indo-Pacific, barracuda flesh has been linked to a condition known as ciguatera poisoning, a serious illness caused by toxins produced by microscopic dinoflagellates that adhere to certain algae species. These toxins are consumed by small herbivorous fish, which are then eaten by larger carnivores. As the toxin moves up the food chain, it becomes concentrated. Barracudas, sitting high in this chain and consuming a wide variety of reef fish, often carry some of the highest toxic loads. Ciguatera poisoning in humans is unpredictable. The fish may show no signs of contamination. Cooking does not destroy the toxin, and the symptoms, which range from gastrointestinal distress to neurological confusion and even reversals in temperature perception, can last for days or weeks. Some cases become chronic. This makes the barracuda in some regions a paradox. Respected as a powerful predator, sought after by game fishers for its fight, but also feared at the dinner table. It embodies both physical danger and invisible risk, a predator that can strike even after death. On the reef, its reputation among other species is just as complex. Smaller predators treat it with caution, not because it attacks them directly, but because it disturbs their rhythm. It doesn't rely on stealth in the traditional sense, but on unpredictability. Even prey fish that escape a barracuda's strike often remain unsettled long after. The fear it generates is environmental, a constant pressure that influences behavior more broadly than any one kill. Despite their solitary appearance, barracudas do sometimes aggregate. Schools of juveniles are common, forming tight, coordinated groups that move like silver ribbons through the water. These young fish feed on plankton and small crustaceans until they grow large enough to hunt alone. In rare instances, adult barracudas also form groups, not to hunt cooperatively, but possibly to share prime hunting zones. These aggregations are tense, temporary, and never quite social. In the shifting mosaic of coral ecosystems, the barracuda fills a niche that is both narrow and far-reaching. It doesn't build the reef. It doesn't clean or cultivate. It doesn't engage in cooperative hunting or elaborate communication. But its presence is felt in every layer of the food web. Its strategies force change. Its kills create openings. Its shadow sends messages without words. What makes the barracuda so effective is not raw power, but control. It holds back when it could lunge, waits when it could chase, and lets others do the work when it suits. Its weapon is not just speed, but restraint. And in an environment where survival often favors the fast or the hidden, the barracuda thrives by doing neither. It simply appears, shimmers, and chooses the exact moment when presence becomes force. That moment, precise, measured, and deadly, is what makes the barracuda one of the reef's most efficient predators. Not the loudest, not the largest, not the most complex, just the most present. A silver blade suspended in water waiting for the gap. In the shaded crevices where the reef breaks into narrow alleys and overhangs, the water thickens with suspended silt, kicked up from below by a sudden motion. A quick shift in current reveals the source, a grouper, not a flash of color like a parrotfish or a darting silhouette like a wrasse, but a bulky, powerful mass of muscle and attitude, moving with the steadiness of a tank and the subtlety of a wrecking ball. Grouper fish, particularly the larger species like the giant grouper or the Nassau grouper, aren't subtle predators. They don't sneak or chase, they corner. Hovering close to the reef wall, the grouper stays almost still, save for the slow undulation of its wide, fan-like pectoral fins. Its mottled skin, patterned with patches of sand tone, slate or muddy green, blends seamlessly with the coral and rock. But the stillness is deceptive. When the moment is right, the grouper moves with explosive force. With a sudden lunge and a wide-open mouth, it creates a vacuum that sucks in not just the prey, but water, silt, and whatever else is unlucky enough to be caught in the blast radius. That mouth, cavernous, hinged, and nearly the size of a basketball in large individuals, doesn't bite as much as inhale. The impact disturbs the seafloor, stirs up benthic organisms, and flushes entire families of shrimp, brittle stars, and burrow-dwelling gobies into the open. But the grouper does not always hunt alone. In some of the most fascinating displays of interspecies cooperation in the animal kingdom, groupers have been observed teaming up with both moray eels and octopuses to extract prey from the reef's labyrinthine interior. The tactic is as strategic as it is violent. The grouper, limited to attacking in open space, cannot reach into the narrow holes and crannies where fish hide. But its partners can. A grouper will often initiate the collaboration, with a distinct, rapid head shake, and in some species a shift in skin coloration. It signals to a nearby moray eel or octopus. These signals are more than random gestures. They are intentional invitations. The eel responds by slithering into the reef's gaps, weaving through the coral skeletons and pressing into the holes where prey has taken shelter. Fish that might have hidden from the grouper now face a new threat, one that can twist and pry them loose. If the eel flushes them out, the grouper is waiting, mouth agape, ready to engulf them in a single snap. In some cases, when the eel or octopus catches the prey first, the grouper does not interfere. The interaction benefits both. They take turns and they remember. These tactical partnerships don't occur by accident. In reef systems with high predator density, the advantage of cooperative hunting is enormous. The combined strike zones of grouper and eel, or grouper and octopus, increase the success rate for both parties and decrease the time and energy spent on a single kill. Over time, groupers appear to recognize specific eels and seek them out, forming preferential hunting bonds. This level of partner recognition suggests more than simple instinct. It hints at memory, spatial awareness, and a surprisingly nuanced form of problem-solving in fish often viewed as blunt instruments of predation. Despite their cooperative flair, groupers retain a distinct hunting style of their own. Their ambushes are calculated, their movements deceptively slow until the strike. They rarely pursue fleeing prey over long distances, instead relying on anticipation, timing, and terrain. Larger groupers often hover near junction zones in the reef, natural funnels where fish traffic is highest, and wait. When prey enters the strike radius, the grouper doesn't lunge forward as much as it expands toward its target, distending its jaw and body in a fluid surge of muscle and suction. The result is abrupt and final. There is no second attempt. But not all grouper behavior revolves around hunting. When the full moon aligns with tidal cycles, thousands of groupers migrate to specific spawning sites, often returning to the same reef ledges or slopes year after year. These spawning aggregations are among the most dramatic biological events on coral reefs, attracting groupers from across entire archipelagos. At peak density, the water churns with their bodies, males and females releasing clouds of gametes in synchronized bursts. The water becomes milky, disorienting, even suffocating to nearby species. But it also becomes a beacon. Predators arrive in waves. Barracudas dart through the outer edges of the group, snatching distracted spawners. Reef sharks patrol just beneath the surface, striking from below. Even dolphins, usually associated with open water, have been documented encircling these gatherings, exploiting the confusion to drive groupers apart and pick them off. The frenzy creates a temporary shift in the reef's food web, as top predators exploit the vulnerability of a species usually dominant in its territory. And yet, this vulnerability is part of the grouper's ecological power. The massive influx of eggs and larvae during spawning season becomes a nutrient surge, not just for those who consume the adults, but for filter feeders, plankton grazers, and juvenile reef organisms that feast on the byproducts. The spawning doesn't just replenish grouper populations, it infuses the reef with energy and sustenance from the top down. In this way, the grouper's reproductive act becomes a keystone event, fueling species that have no direct connection to it under normal circumstances. Even outside of these peak moments, groupers affect the reef's micro-ecosystem simply by existing. Their constant gulps and surges disturb the sediment in ways that create new pockets of shelter. Shrimp take advantage of the loosened substrate. Juvenile fish use the silt clouds as cover. Sessile invertebrates, like feather duster worms and sea pens, benefit from increased nutrient flow. Every feeding lunge of a grouper is a miniature geological event, shifting terrain, creating turbulence, and redefining the physical space that smaller animals must navigate. Yet for all their ecological importance, groupers remain vulnerable. Overfishing, especially during spawning aggregations, has decimated populations in many parts of the world. The very predictability of their behavior, their loyalty to spawning sites, their territorial fidelity, makes them easy targets. In regions without strong protections, entire age classes have been wiped out in a single season. This loss is not just a hit to grouper numbers, but to the reef systems they help maintain. Without them, sediment control declines. Cooperative hunting behaviors vanish. The feeding networks that once radiated out from their movements begin to collapse. In some protected areas, however, grouper populations have rebounded. With time, their behaviors return. Spawning sites come back to life. Eels and octopuses resume their unlikely partnerships, and the reef, shaped again by the steady rhythms of suction and strike, finds its old balance. It is a reminder that even the heaviest hitters on the reef are not isolated forces. They are woven into every crevice, every cloud of sand, every flick of a shrimp's antennae. The grouper is not elegant, but it is effective. Not fast, but deliberate. Its body is a tool shaped by reef warfare, powerful, simple, adaptable. And though it may not chase or soar, it dominates by patience, by leverage, by knowing exactly when and where to open its cavernous mouth and reset the rules of the game. In the architecture of coral life, the grouper is both demolition crew and foundation stone, knocking loose the pieces that others survive on and holding up the very structure that defines the reef. Beneath the churn of shallow surf, where shafts of light strobe across the reef and the soundscape crackles with the clicks of snapping shrimp and the hum of distant currents, a peculiar sound stands out. A crunch. It echoes in small bursts, irregular yet persistent, like gravel ground beneath boots on limestone. Follow the sound, and you find the source. A parrotfish. Its beak-like jaws, named for their resemblance to the hooked bill of a parrot, clamp down on coral with remarkable force. With each bite, the animal isn't just grazing algae off stone. It's devouring the very structure of the reef, chewing calcium carbonate skeletons into fine powder. Up close, the parrotfish seems ill-fitted for the destruction it causes. Its colors are often riotous. Streaks of blue, neon green, magenta and gold wash across its scales in patterns that seem more ornamental than predatory. But this is no idle reef wanderer. It's a biological jackhammer, engineered to sculpt its habitat with relentless efficiency. As it feeds, it grinds the coral into sand within its specialized pharyngeal teeth, a second set of molars deep in its throat, before expelling the material as a soft stream of sediment. One individual can produce hundreds of pounds of sand each year, building entire beaches from the pulverized remains of reefs. What appears destructive is in fact part of a complex balance. Parrotfish serve as ecosystem regulators, the reef's landscapers and janitors in one. By constantly grazing, they strip away turf algae that would otherwise overwhelm living coral. Reefs without parrotfish quickly tip into decay. Algae, unchecked, forms dense mats that smother coral polyps and prevent new larvae from settling. In this way, the parrotfish, with its grinding jaws and messy feeding habits, maintains space for coral to breathe, grow, and compete. Its appetite is the reef's defense against suffocation. But the parrotfish's impact doesn't stop at the coral surface. Its leftovers become a resource stream. As it grazes, it dislodges crustaceans, brittle stars, and minute snails that wrasses, gobies, and blennies immediately dart in to collect. Crabs follow closely behind, scavenging the loosened bits of algae and debris. This chain reaction, triggered by the parrotfish's rough dining, fuels a constant churn of energy along the reef's surface. A localized storm of opportunity for smaller species with faster reflexes. Their role in the food web is not always passive. Parrotfish, especially when feeding in groups, create spatial patterns in coral that influence reef architecture itself. Grazed areas become recruitment zones for coral larvae or cleared patches that may later be overtaken by sponges. Over years, this cumulative effect reshapes the reef's topology, flattening some ridges, exposing old coral beds, opening crevices that become microhabitats for shrimp, worms, or even nesting damselfish. The fish becomes in essence both the reef's gardener and its sculptor, pruning the overgrowth and chipping away at the hardscapes simultaneously. At night, their behavior changes radically. As the sun sinks below the horizon and the reef's cast of predators begins to stir, moray eels sliding from caves, nocturnal sharks sweeping past drop-offs, the parrotfish does something few would expect from a brute coral grazer. It hides, not by burrowing or wedging into a hole, but by spinning silk. From glands near its gill covers, it secretes a transparent mucus that quickly envelops its entire body. Within minutes, it is encased in a gelatinous bubble that clings loosely around its form, drifting slightly with the motion of the water, but always sealing back in place. This isn't camouflage in the visual sense. The bubble doesn't change color or mimic texture. Instead, it acts as a chemical cloak. Moray eels, with their exceptional ability to track prey through scent trails in the water, pass right over a sleeping parrotfish sheathed in this mucus cocoon. The bubble masks the fish's odor signature, severing the chemical breadcrumb trail that would otherwise mark its position. It's a strategy rarely observed elsewhere in the animal kingdom, and among fish, it's almost uniquely bizarre. Some species even reinforce their bubbles with a thin lining of antimicrobial agents, protecting not just from predation, but from infection during their vulnerable rest. These night bubbles are more than defensive devices. They mark a transition from the hyperactive pace of daytime feeding to the passive risk management of reef nocturnes. For a fish that spends the day grinding coral with the force of industrial machinery, this nightly vulnerability is striking. A reminder that power alone doesn't guarantee safety in a habitat where everything becomes food at some point. As much as they shape the reef's structure, parrotfish are also entangled in its energy flow. Their waste, rich in digested algae and mineral powder, alters the chemistry of the surrounding sediment. Some microorganisms thrive only in the nutrient-rich outflow of parrotfish. In certain lagoons, bacterial communities bloom in direct correlation with their presence, shifting the microbial baseline and even affecting the water's light-scattering properties. These microbes, in turn, feed filter feeders like sponges and bivalves, linking the parrotfish's digestion to the reef's nutrient recycling engine. Even more intriguing is their role in sexual dynamics. Many species of parrotfish are sequential hermaphrodites, born female, transitioning to male as they grow. In some, the dominant male develops a distinctly different coloration, becoming a supermale that controls access to harems of females. But when the supermale dies or disappears, the most dominant female can transform into a male, adjusting not just behavior but body morphology, hormone levels, and gonadal structure. This plasticity helps stabilize populations in environments where external pressures, fishing, habitat loss, disease, can unbalance sex ratios. In other words, their biology is tuned not just for coral consumption, but for reproductive resilience. Yet this resilience has limits. In regions where parrotfish are overfished, the consequences reverberate outward. Coral cover drops, algal mats creep in. Beach formation slows as sand production declines. Fish that once depended on parrotfish leftovers lose their feeding niches. Predators that targeted parrotfish turn to alternative prey, disrupting predator-prey ratios. Even the nighttime reef becomes louder with the absence of crunching jaws, a subtle but telling absence of industry. In marine protected areas, however, where fishing pressure is relieved, the return of parrotfish is one of the earliest signs of reef recovery. Coral recruitment improves. Grazing scars appear again, not as wounds but as evidence of a system being actively maintained. Sediment plumes drift like silted breath over the reef, signaling that the sculptors are back at work. Watching a parrotfish up close, its jaws flexing, its pectorals fanning like stabilizers on a slow-moving submarine, the instinct may be to marvel at its color, its chunking power,
or its night bubble oddities. But its real legacy lies not in any one behavior. It's in the accumulation of tiny acts repeated over years, one bite at a time, one grain of sand at a time, reshaping not just the reef beneath its jaws, but the coastline of entire islands. The parrotfish is not simply a grazer. It is a builder, a filter, a chemical manipulator and a shapeshifter, part artist, part engineer, quietly redrawing the boundaries of the coral world, whether by day's light or under the ghostly shield of its glassy nocturnal veil. In the filtered light of the shallow tropics, where salt hangs in warm currents and the water's surface flickers like molten glass, a coral reef stretches across the seafloor, not as a static monument, but as a layered living engine. From above, it may appear motionless, its contours soft and pastel beneath the waves. But peer below the surface long enough, and the illusion of stillness vanishes. What lies beneath is not scenery. It is choreography. Movement layered upon movement, built from instinct, memory, hunger, and cooperation. This is not just a reef. It is a symphony. And its composers are not coral alone. The base of the reef, its limestone bones, was secreted over centuries by colonies of coral polyps, no bigger than sesame seeds. But the skeleton means nothing without the life that animates it. Each fish, each crustacean, each predator and grazer contributes to the maintenance, architecture, and composition of the reef's form. A green sea turtle carves algae highways across coral plateaus, not for destruction, but to stimulate regrowth. Where it grazes, coral polyps gain space to re-emerge, liberated from suffocating algae. Its shell, rough with biofilm and barnacle, becomes a mobile ecosystem, a drifting reef fragment. And the turtle, in its habitual routes between grazing zones, links reef patches together like a biological bridge. Beneath its shadow, parrotfish rasp through coral with their beak-like jaws, not out of malice, but to access the nutritious algae within. Each bite sends tiny clouds of carbonate silt into the current, sand in the making. These sands drift into lagoons, gather along island beaches, or settle into reef crevices, where they affect water flow and sediment composition. The parrotfish is not just a grazer. It is a sediment engineer, one whose waste defines the very texture of reef geography. Nearby, a barracuda waits, hovering in the shadow of an outcropping, motionless but wired with latent energy. It is not an active chaser, but a calculator, watching for the briefest misstep. Juvenile jacks and wrasses adjust their school shapes and swimming patterns based on its position, learning over time which ambush paths it favors. In this way, the predator reconfigures traffic, not by action, but by presence. The reef adjusts itself around the barracuda's gaze. Higher in the water column, where sunlight still penetrates, but the reef begins to give way to blue void, manta rays wheel in slow, deliberate spirals. To the untrained eye, these loops appear like idle gliding, effortless and serene. But closer inspection reveals the architecture in motion, a cyclonic feeding pattern that concentrates plankton into a dense column, allowing the ray to maximize intake with minimal effort. Other filter feeders, juvenile trevally, pilotfish, remoras, position themselves along the ray's path like birds drafting behind a thermal. In this spatial dance, the manta creates opportunity not just for itself, but for those that understand its logic. Beneath them all, in the nooks and caves of the reef's base strata, groupers lurk. Heavy-bodied and patient, they coordinate with moray eels and octopuses, flushing prey from bolt holes in a display of interspecies strategy once thought impossible for fish. Their gulps stir sediment, influence micro-ecosystems of worms and shrimp, and trigger localized feeding events that attract scavengers from meters away. Each attack echoes outward, a shockwave in the reef's nutrient web. This interconnectedness deepens as night falls. Diurnal fish disappear into coral crevices. Nocturnal hunters emerge: lionfish, squirrelfish, reef sharks. Parrotfish spin mucus cocoons that not only shield them from predators, but influence microbial colonies around their bodies. The reef's oxygen balance shifts. Polycate worms rise from the sand. Crabs reposition themselves along water flow vectors to intercept drifting plankton. The environment turns over, not like a machine switching states, but like a civilization rotating through different castes. Even floating refuse, a plastic bottle, a drifting patch of algae, the shadow of a dead tree limb, becomes colonized, forming temporary reefs in motion.
Blue sharks follow these structures for flying fish. Birds rest atop them, and juvenile fish seek shelter in their shadow. The reef's influence extends well beyond its limestone border. Its effects ripple into the pelagic. The open sea becomes an extension of its influence. What emerges is not a food chain, but a scaffolding of behavior, shaped by evolutionary history and daily negotiation. Coral is only the substrate. The builders are many, each species manipulating its layer, reshaping microhabitats and setting conditions for others. There are no true spectators here. The cleaner wrasse that nips parasites from the skin of passing giants alters predator behavior. The snapping shrimp hiding in sponge burrows modulates soundscapes that affect mating calls and territorial disputes. Even the territorial damselfish, fiercely guarding algae patches, shape coral growth by pruning overgrowth and directing water flow with their nest placement. Coral itself is not a passive player. It grows in patterns that create current channels, wave deflectors, and shaded sanctuaries. It emits chemical cues that attract larvae, deter predators, and even influence the microbiota of neighboring polyps. But its success depends entirely on the fish that clean it, the invertebrates that defend it, and the sediment cycles managed by grazers and builders. Reef building in the broadest sense is not the work of coral alone. It is a community act, replayed daily in thousands of unseen transactions. Even death plays a role in this symphony. A fallen grouper carcass triggers a feast. Scavengers consume it in layers, flesh first, then organ, then cartilage, until only jawbones remain. These settle in a depression, become coated with algae, then overgrown by coral, absorbed into the reef's geometry. Bones become scaffold. Decay becomes template. Life grows atop the memory of the last cycle. When viewed from this angle, the coral reef ceases to be a habitat in the static sense. It becomes more like a coral city, one with vertical zoning, behavioral corridors, and fluctuating population densities. Each animal is both citizen and architect, both user and builder. The reef doesn't simply respond to life, it is shaped by life. Every sand grain laid down by a parrotfish, every ambush avoided because of a barracuda's glare, every lava that settles where a turtle grazed the day before. These are bricks in a structure too dynamic for the eye to catch in a single glance. This is the Strata Symphony. It plays not through melody but through rhythm, the rhythm of movement, change, adaptation, and co-creation. The pulse of a reef is measured not just in waves or tides, but in the converging and diverging paths of its builders. And as climate pressures rise, as bleaching events reshape coastlines and predator patterns shift, this symphony is strained, retuned, yet still audible. The reef is not the backdrop, it is the narrative. Every animal we've followed, from the manta ray's orbit to the crab's crevice, is a co-author. Each moment they act, rest, feed, or die, they are writing another line into the reef's evolving script. And while no one conductor directs this orchestra, the harmony is undeniable. It is built from action, not design. The coral reef survives not because it is beautiful, but because its inhabitants build it together, layer by invisible layer, breath by tidal breath.